Continue on that immediately. I'm a little bit behind my planned schedule for the talk, so I'll skip a couple of the word classes I was planning to talk about. But prepositions are important, so let me say how I interpret prepositions. And again, I formulate a semantic hypothesis for these prepositions. And once again, prepositions denote convex regions in a single domain. You're beginning to recognize this formula now, I think. Now, an important thing to notice is that there are prepositions for different domains. Many of them, not all, but many of them refer to the spatial domain, like above. And I will mainly talk about the spatial domain. But actually, some of the prepositions refer to the force domain, and that may come as a slight surprise to you. And I will argue that the prepositions like on and in actually involve force elements. And then you have time domain like during and before and after and stuff like that. And there are even epistemic domain prepositions like despite and so on, but I won't have time to talk about these. So again, I'm claiming that the basic meaning of a preposition builds on a particular semantic domain, and within this domain they correspond to convex regions. One complicating factor is that prepositions are very often metaphorically used. So you can see them used in other domains, and that makes the story more complicated. But I'll get around that. So Michael talked about when he talked about prepositions, he talked about angles and distances. And that's a way of saying that what you need when you describe prepositions is to use polar coordinates. Polar coordinates are defined in terms of angles and distances. In most cases, you seem to think, in most cases I've been talking about when I talked about Voronoi tessellations and so on, I've assumed that we have a Euclidean geometry with Cartesian coordinates in x and y and so on. But now I'm shifting, and I say that for prepositions, and actually for the CARLA space as well, you need to do convexity in terms of polar coordinates. And once you do that, you get a very systematic analysis of prepositions. And I wrote a paper together with Joost Swartz, and it was published a couple of years ago, where we did all this work for a class of prepositions. So polar coordinates, you have one angle, two angles, if you have the three dimension, and one distance, the r here. But I'm not getting into the mathematical details. The important thing is that if you do the polar coordinates, convex sets will look differently. So one example is that if this is a landmark, and this is one point B here and another point A, this is a convex set because it's all at the same distance. You can have a definition of convexity for polar coordinates, and that will be a convex line in polar coordinates. You have the fixed distance, and then just varying the angle. So convexity is dependent on what kind of coordinate system you're using here. That's a thing I haven't talked about before, but it actually applies to as I said, the CARLA space. And once you have seen this idea, then you can go on and do all the. So I'm assuming that we have a landmark. Polar coordinates presume an origo, a fixed point, and now the origo will be a kind of landmark for a prepositional. So I'm assuming that we have a circular landmark just to make things easy. And then we make a distinction between inside and outside. This is the region here inside the landmark, and this shaded area here is the region outside the landmark. Both of these are convex if you do polar coordinates. So if you do near and far, you have some kind of contextually, this is the landmark, contextually defined distance that is near. Then this region is what is near, and that region is what is far. Again, both these regions are convex. If you do front, back, left off, right off, Michael had lots of examples of that. You will get these regions, or maybe narrower version of them, as you saw in the robot cases. But basically, they are all convex. Now the distances are variable, but the angles are within a certain region. So all these locational prepositions. I mean, they're talking about locations of objects. They came out as convex regions. And if you introduce the third dimension, you have the vertical dimension. You can have above and below, and then again you get convex regions. And between, which involves two objects, you get something like that, and that's basically also a convex region. There's a bit of complication here, but I don't want to get into that because you have two origos here. But anyway, that's locational prepositions. Now, I can also do this for directional prepositions. So directional prepositions are things like to and into, onto, towards, and so on, and source prepositions from, out of, away, and from. I mean, that's another class of prepositions.
Maybe a very stupid question in between. I don't have any math background, so I just wondered, is it possible to just transform anything that's not convex into something that's convex by just introducing a new system of coordinates?
No, the answer is no. And there are not too many possible, or I should say reasonable coordinate systems. And there are, sometimes we have good cognitive reasons for having a Cartesian one. And we think that in our math education we normally do only Cartesian coordinates. But perceptually, I mean, this angle and distance is in a sense more natural way of representing a location. And if you do that, you get a different form of convexity. But I mean, your point is good here, because we have to decide on the coordinate system before we start talking about what is convex and not convex.
Inside the UK, for example, how that would translate to real objects. So, like, if you had a container, like a bowl or something, or say inside the mug, is really dependent on the shape of.
Yeah. Now I'm making a bit of a simplification here by assuming that they only have circular objects. If you don't have it, you may get a little bit of a trouble with the convexity in terms of polar coordinates. So it's a bit of a simplification, but basically this is how it works. So I'm assuming I'm giving myself some leeway here by only using, but basically this is. The regions would be basically convex in any way if you have an object of a different shape. Yeah, but that's also a good point. Now, and you have in this class directional prepositions. You also have rote prepositions: through, over, along, around, and across, and so on. They talk about They have a starting point and an end point. All of these prepositions, and we analyze them in terms of paths. You start from a particular position, you end up in another position, and there is a path in between. The set of paths is a set of objects, and you can define convexity on the set of paths. So let me just give you one example. Into. I mean, this is one path of going into. You start from here, and then you get into the landmark, and you start from here and you get into the landmark at a different point. But this path will be between here. I mean, and it's a very simple mathematical trick to define what it means that one path is between two other paths. So convexity on path is also well defined. And if we do on all these, we do the analysis. I mean, we describe the criteria for moving into. Basically, moving into means that the initial point of the path is outside the landmark, and the final point is inside the landmark. And then that defines a class of paths, and that class of path is a convex set. And we can do the similar thing for all of these prepositions, and all of them turn out to be convex in terms of sets of paths. So that's the directional prepositions. That's the into stuff. I've done that. Then we can go over to prepositions that are not spatial. They depend on forces. And this is an example from Annette Herskowitz's old book on prepositions. This is a pair. And we would say that the pair is in the bowl. But here is the pair is hanging from something else. And it's exactly the same spatial location But we wouldn't say that the pair is in the bowl. I mean, actually, it's not really. I mean, if you draw the line here, it's above the bowl in spatial terms. But why do we say that it's in the bowl? What is the reason for saying that this is in the bowl, that is not in the bowl? Yeah. That's part of the answer. There is there is some kind of connectivity here. But that connectivity, okay, maybe you want to try to answer it. Or? Location control, yeah, good. So that's basically the right answer. If you move the bowl here, then you move these apples or whatever they are, and the pair will move. If you move the bowl here, the pair won't move. So there is a kind of, the container is exerting some kind of force on the pair. That's a kind of control. And that's the force relation here.
So I agree that force obviously plays a big part in these propositions, but would you not include it including any spatial dimension? I don't really see why you restrict having to be one dimension being force dimension. The notion of containment of the in is very strong as well, spatially.
I guess I would have that as a side condition. That there is a kind of, in requires a landmark that is some kind is a container. Yes. So, but that doesn't mean that the preposition as such as. I mean, it's a side condition of the in application here.
In cases where, say, the landmark is not a rigid object, something you can pass through, so it wouldn't really exert any location control. Or if you have four boxes.
Yeah. Look at the difference between in and inside. Inside is a spatial preposition. In, I would claim, is force. That's well. We have to look at all different examples, but that would be the main reason why we make a distinction between in and inside. Inside is definitely spatial. So you can be inside a tunnel without being. Yeah. Okay. Here is another example, on. And normally we think of on as, I mean, this cup is on the table. It's kind of spatial connection. It's in contact and so on, but it's above. But I would say that's not enough. So my question is the lamp, in this case, is the lamp on the balloon? No. I mean, English speakers people normally don't say it's on. Because here, it's not the balloon that supports the lamp. It's the other way around. I mean, the balloon is lifting. It's stopped by the lamp. The force direction is in the other way here. Yeah.
Would you say that the balloon is on the lamp?
Okay. We say that the fly is on the ceiling. So I mean that's there is some kind of force connection here. The feet of the fly stick to the ceiling. Yeah? So the fly is on the ceiling. We also say that the board is over the hole in the ceiling, even if there is no hole here, but we could think of a hole and we put the board over the hole, even if it's under spatially. So this is the covering meaning of over. You may be familiar with Lakoff's and what's her name? Who did it first? Okay, anyway, there is a lot of analysis of the over preposition. But I would say that over is a force relation. And one test you can make for these things is that if you rotate them, if you rotate the ceiling and still move the board, it will all the time be over the hole. Over the hole in the ceiling. Or one of Lakoff's example is the veil over the face. The veil is not, it's in front of the face, but it's still over, it's covering. There is some kind of force relation here as well. Here is another example. It's an experiment by, I think, Simon Garrett, if I remember correctly. So you ask people, is this man holding the umbrella over his head? Is he holding the umbrella over the head here? And here, of course, most people say yes, and here most people would say no. But if you then introduce the rain here, so you get the wind as a kind of force direction, force element here, then most people would say that this man is holding the umbrella over him, because it's covering from this force thing. Yeah. So I mean, these are my quick arguments for why some prepositions are based on the force domain rather than. Of course, forces need a spatial structure to be. There is always space around, but this is the question of what is the more primitive meaning of the force. How much can you vary the spatial location and still keep the force direction? And that's why I talked about turning the border over the hole, and that will still be over independently of how you turn it. Or if you have the veil over the face, it will be over independently of how you turn the woman. Yeah, okay, that's all I have time to say about prepositions. But I do this idea again about the single domain hypothesis here. I'll say a few words about the demonstratives, because I've done some work on it quite recently. In English, we don't have very many demonstratives. I mean, very pure demonstrative. There, basically, you have, these are the four most common ones, and they form a word class of their own. Holger Diesel have argued that demonstratives are really a separate word class. Now, this and that refer to objects in category space. And this is typically an object that is close to you, and that is an object that is far away from you. So there's a kind of similarity between near and far in this and that. And similarly for here and there, which refers to physical place. Again, here is something that is close to you, and there is something that is far away from you. Some languages have a tripartition, or quite a number of languages. You have near, in between, and far away. English has an old word, yonder, that means really far away, which is getting obsolete more or less, I think. So this is English, very meager word class actually. And the communicative role is to create joint attention. I mean, I'm using that as part of a dialogue to help you identifying an object. I mean, the bottle over there rather than the bottle here. And when you learn it in combination with pointing. Children learn demonstratives quite early, as a matter of fact. And then you learn it to talk about, you say this man and that without actually pointing to it in the real world. You use it as a part of a reference to an earlier thing you talked about in the dialogue. There are other languages that, you can say that what happens is you're pointing to the inner world instead when you have it as part of a common ground. There are other languages that have richer demonstrative systems. And I've done some work with Maja Brala, who is a Croatian linguist. And Croatian is a Slavic language. It doesn't have determiners. And one way of getting around the problem of identifying reference is to have a rich system of demonstratives. So they have this proximal, medial, and distal. I mean, all the words in capital letters are Croatian words here. And then we analyzed all these words in terms of the domains here. So you have location and path. You have the similar thing as with prepositions here. You have demonstratives related to objects, that is this and that. But you also have demonstratives related to action and to discourse. So it's a much richer system of demonstratives. But it still fulfills this idea of referring to a single domain. Okay, demonstratives. Now I summarize my analysis of the word class. I didn't have time to talk about the adverbs. I skipped that, but basically, adverbs function. I only look at adverbs modifying verbs, and then they function like adjectives. They're modifying vectors. and you get some kind of multiplying phenomena here. But I've talked about object concepts represented by nouns, properties represented by adjectives, domain relations, spatial relations or force relations represented by prepositions, force and result vectors represented by verbs. I didn't say much about this. And then present entities when you have demonstratives. And events I modeled with sentences. But the common thing here is that for all these word classes, I've put forward this thesis that they all depend on a single domain, and the words within the word class refer to convex regions of the corresponding domains. So that's a kind of unifying view of word classes. Now, what makes the word classes different is that there are different domains and there are different categories, so to speak, that you use when you form the convexity relations. That was quite clear in case of prepositions, where you either had locations or where you had paths as the things that define the convexity. Now, what is the point of this? Well, the point is that we go back to my original question here. How can children learn things so quickly? And how can children learn words so quickly as they do? And I have given basically two answers to help. I haven't solved the problem, but I've given two cues to how it works. And one cue is that the spatial structures generate relevant regions. So once you have understood what the color space is, once you have understood what we talk about when we use color words, then you can very easily learn new color domains. Because the space is there, you just have to find out what region a particular word is referring to. So once you have learned to understand a particular semantic domain, it's quite easy to learn new words given the spatial structures that you have picked up. And then now, the second answer is this analysis of word classes, where once you understand that something is a verb, then you know as a child that it either refers to some kind of action, some kind of force pattern, or it refers to some kind of change in the patient here. So word class markings, here I bring in a small part of syntax, will help you in understanding what kind of meaning are we talking about. Is it a property? Then, if it's an adjective, then we talk about the property. If it's a noun, then we talk about the complex of properties. If it's a verb, then we talk about either an action vector or a result vector. So these word markings help children pick out what is the relevant sort of meaning that you're supposed to pick up when you learn the meaning of the word. So this doesn't answer the question of word learning in total, but these are two elements in why children are so good at learning these meanings. Okay, that's the end of the cognitive theory of cognitive grounding of word classes, and part of that was this part. Now I get to the final topic here, and that's compositionality of meaning. I don't have a full theory of compositionality, and I will focus on adjective-noun combinations because they are the kinds I can handle with using conceptual spaces. But I think you will see that the spatial structures here will also help in understanding the meaning of compound words. We could discuss other kinds of combinations, but I haven't prepared very much on them. So if we look at, say, adjective-noun combinations, you can basically talk about three kinds. One is direct combination. like in blue book or blue bottle. There is no direct problem with that. Then you have something where there is a modifier in the head. I'll give you an example where something like tall squirrel or a small elephant. A small elephant is still a big animal. That you have to have it relative to the head here. And then there are metaphorical uses, and I'll say a few words about metaphorical word combinations. Not very much. Time is running fast here, but still, please interrupt me whenever you need to. So let's do Okay, that's another point. most theory of linguistics, most theory of composition in linguistics and in philosophy think of composition as composing the meaning of words. I take a much more general perspective, and I think of composition as putting together domains and the mappings on domains. So for me, composition is composition of domains, not composition of words. So let's do a direct composition. Single thing is blue rectangle. Then you can take the product space. You have a color space, and now I represent the color space with one line here, even though color space is three-dimensional. And I represent shape space with one dimension, but shape space is probably high-dimensional. And then you can say that, okay, you have this part of shape space represent rectangles, this part of color space represents blue, and then this part of the product space will represent blue rectangles. I mean, that's simply making the product space taking the intersection of the two regions in that space. Nothing is sensational, and that works very well for the cases where there is no conflict between the head and the modifier here. More interesting is when you have, I'm sorry, the structural properties of conceptual spaces are preserved under, so you have the convexity is preserved when you have a product here, and some other properties of the spaces, they are preserved here. I don't want to, I mean, that case is kind of uninteresting. Let me get into the more interesting cases, modifier head composition. That's what most linguists have been and philosophers have been working with. So let's have, I mentioned tall squirrel. Tall squirrel is not a tall animal. It's dependent, so that's a bit difficult. Honeybee is not, it's not an intersection between honeys and bees. It's called honeybee because the bees make honey, in contrast to maybe some other bees. I don't know what the contrast is. Well, criminal lawyer is actually ambiguous, but the real meaning is, or one meaning is that it's a lawyer that takes on criminal cases in relation to a family lawyer or whatever, in contrast to a family lawyer. So that's another example. And we have the famous stone lion. A stone lion is not a lion. But what is it? What is the meaning? How do we know immediately what is the meaning of a stone lion? Or a plastic duck, if I give you another example of the same type. And we know immediately what the meaning is. I mean, for honeybee, we need to know a little bit about bees in order to know what it means and so on. And then we have my favorite German example here, Leberkäse. This literally means liver cheese. But it's neither cheese nor liver. It's something else. It's a kind of food. So it has it has the texture of cheese to some extent. And I guess that it was originally made from liver, but it's not made anymore. I don't know. Anybody knows what Leberkäse is made from? It's maybe you don't want to know. Anyway, that's a case. So how do we handle these cases? I don't have solutions to everything, but I can give you some cases where the conceptual spaces approach will really be helpful. Of course, concepts are sensitive to context. Tall means different thing when you talk about mice and when you talk about elephants. And I have the example of that hot bath water is not a subcategory of hot water. I mean, so when you do, if you look at tap water and you say that this tap gives me hot water, then you would say that, okay, tap water is typically between 0 and 60 degrees, I think. I mean, it's roughly that region. And hot means, in this case, I mean, it's a temperature dimension, and hot means belonging to the upper part of this dimension. Maybe it's not directly from 30, but at least the upper third would be hot. Now, if you talk about hot bath water, you wouldn't expect something to be 0 degrees and be called bath water. I mean, the typical range of bath water is perhaps something between 25 and 60, or maybe even hotter. I don't know what is the range of, but anyway, it's a kind of sub-region of the tap water region here. And now this sub-region, then you would say that something is hot bath water if it belongs to this region, not to that region. So I hope you see that it's the same object, but depending on whether you describe it as bath water or just as water, you can categorize it or as, in this case, it's hot, but if it's bath water, it's not hot. So you have to be aware of the contrast clause here. So I give you another example. Please interrupt me if I mean, now I'm speeding up in my talk here, but still please free. So I'll give you another example. We take the seemingly innocent word red. And this is the definition of red in the Advanced Learner's Dictionary of Current English. So they define red here as a color, and then they give examples. Fresh blood, rubies, human lips, the tongue, maple leaves in the autumn, post office pillar boxes in Great Britain. This is an exemplar definition of red, and from that you're supposed to extract what color red means. Now that is the standard meaning of red, but if you look at combinations in English, you get things like this: red book, red wine, red hair, red skin, red snapper, red wood. The list can be made much longer, but I've just picked these examples here. Red book is fine because this is a kind of the direct composition. Books can have any color. Red book means of this color. Red wine is not red according to this definition. Red wine is dark purple, whatever. Red hair is not red. It's maybe copper something. Red skin is not red. It's pinkish something, pinkish brown. Red snapper, I don't know what color it is, but it's definitely not this color. Redwood is very lightly reddish brown as well. But we still use red in all these cases, and some of them are quite productive. I mean, red wine, you have white wine, yellow wine, and, well, Portuguese have green wine, but that's a different story. You have lots of colors of hair, and you have lots of colors of skin. So I will take the skin example because you can talk about white skin, black skin, red skin, yellow skin, what else, brown, and so on. I mean, you have a lot of color terms that we use to describe the complexion of people. And so my analysis of this is as follows. The yellow dots here are all possible skin colors. We don't really have any white people. We don't really have any black people. We have some variation in the skin color. We don't have any people with colors in the blue-green area. I mean, they're all on the red, yellowish, brownish side here. I mean, I'm not sure that this is a good representation of real human skin color, but let's assume it is. And what happens when you talk about somebody having a red skin or a blue skin, yellow skin, is that you take this is the contrast clause. We know a lot about the variability of the skin colors of people. So we take this clause and then we embed, we make it a transformation of the color space. So make it to fit with this clause. There's what is it called? Multiplication. I'm missing a word here, but it doesn't matter. So we make it fit here. And then it's relation into this color space that we use the color words, the smaller one. So red people would be people with this kind of color. That's not real red, but it's something different. Black people would be people with this kind of color. It's definitely not black. And white people would be people of this kind of color, and so on. And you can even say that you can become green of sickness or green of envy. It's not really, but it's a temporary thing that happens to you. And what happens when you become green of sickness or green of envy is that you lose blood in your face. And losing blood means that you move away from the red side and you move over to this part. And this part is what corresponds to the green part of the smaller space. But actually, if we look at the full color space, what you do is moving from red in towards the gray space. But we still use the term green, even if there is no shade of green in the face. Because that's the part of this color space that we are talking about when we say the green face. So what we're doing here is to take this, we take the contrast class, the possible set of possible skin colors, and then we diminish it. Now I remember the mathematical term is a projection. It's called a radial projection, and then we fit the color space, and then we use that. And I would say that for hair colors and so on, it's the same mechanism. The contrast class of colors may be slightly different, but the mechanism is similar. And this can be used for lots of adjectives. I mean, this kind of principle. Mathematically, I mean, this is just a model of what is meant by radial projection. I don't want to get into that. Lucas.
Quick question. So here we say that red is you basically for many words you use this projection of red. You construct a new space. How does that work with learning? So the child sees all of those instances of red. First of all, you need to construct the overall space and the regions before you can do some simplifications.
Yeah. Good question. I don't know the answer. I don't know if anybody's looked at the answer on how you learn to understand these transformations. We make them very quickly, and we make them automatically, not being aware of them. It presumes that you have some knowledge of the contrast class, that you have learned that people have different skin colors. Otherwise, you wouldn't be able to understand these contrasts. So that would be a constraint on the learning process, I think, in order to have it in a proper way. I don't know. Does anybody know about children's interpretation of these kind of constructions? I don't really know. Okay, then let me go on to the famous stone lion here. Now, here I would go back to my analysis of different kinds of nouns being associated with different nouns. So lion is a typical object category. So it has all these object properties of size, weight, temperature, material, biological properties and so on. And the stone is a mass noun. And if you look at, remember my categorization that I presented yesterday of different kinds. So you would put lion in the class of concrete, and these are the domains that are associated with the lions. And then you add stone, and that's a mass noun. And for mass noun, the material is the most important. For lions, it's the object categories that is the most important. But also other categories are involved here. Lions definitely have shapes, and they are made of flesh and blood and so on. But if you make this composition between stone, lion, I mean, if you add the stone, then this information will block. I mean, will be incompatible with some of these properties. So you can't have material, can't be stone anymore. It can't be flesh and blood anymore. But I mean, we are saying that it's a stone, so we're blocking this. And we are blocking a number of other biological characteristics here, like temperature and agency, and I don't know what we are blocking here. What remains compatible with this stone is the shape. That's the major domain of the lion that is still compatible with adding the word stone. So that means that if we do this domain analysis, we would see that we keep the information about these domains. So that means the object is made of stone, but it keeps the shape information. So that's the meaning of a stone lion. It's an object that has the shape of a lion, but it's made of a stone. I mean, I don't know to what extent we can extend this analysis, but it still builds on this idea that different kinds of nouns have different essential domains, or more or less essential domains. Somebody want? Yeah, go ahead.
So based on this classification, a lion would be unable to be associated with emotion and goal. So it would
A stone lion would be that, yeah, because that also blocks. Something made of stone cannot have emotions.
Also, just a lion, because it's in the concrete category. In the concrete category forbids emotion and goal.
Oh, good, thanks. Yeah, no, I should. No, we should have. You're right. The lion is not only a concrete. It's a living thing. It's an agentive thing. Yeah, thank you. That's sloppy of me. Yeah, it has more properties. It has the agentive as well. Yeah, go ahead.
This is something I also wanted to ask with respect to. You get the example of square water or something. I think in one of the first lectures you had something about water.
Yeah.
Anyway, so this is
I said round water. I think I had yes an example. Okay, go ahead.
So this is supposed to be a model of how we can think, right? This is supposed to be a model of sort of like our conceptual spaces. And what you're saying is, are you saying that it is conceptually impossible for me to think that a lion could move like a normal lion and also be made of stone?
I'm not saying that it's impossible, but if you read or hear this expression, I would say this is your first interpretation of it. Then, of course, we can override that or interpretation with other things, because these are the typical or prototypical things. Now, given your remark, I should have put lion here, but the story would still be the same. Stone would block these. And it would actually block the agentivity of the lion as well. So what remains is again the shape domain. Yeah. Go ahead. You want to?
So still, I mean, like, even if it's my first impression, isn't it supposed to be like a model of my ability to think? And like and the reason I don't think a lion can move in a way it does normally when it's made of stone, is because I have certain knowledge about what the world is like, and not because of some kind of conceptual constraints. But it looks like it's a conceptual constraint that I can't think a certain thing. I can't think that lion can move when they're made of stone.
Yeah. Okay. No. Now, I mean, this is about how we normally interpret things that we hear or read. And I haven't talked about the Gricean principles, but when we assume that if people are informative, they give you the information that you want. And if I write stone lion, and you start thinking of a stone lion that is moving around, I mean, that's not a typical thought. If I wanted you to think of a moving stone lion, I would say that this is a very odd lion, blah, blah, and it's made of stone, but it can still move, and so on. I would be more informative, because I don't expect you, when I say stone lion, you to imagine it to be moving. So if I tell a story about something happening, what should I give you as an example? I mean, if I use the word bird, and then I tell a story about something that is clearly, I mean, it can't fly and it can't sing and it lives in environments to minus 50 and so on. And then you would expect me to say penguin in the first place, because that would be more informative. A bird gives you some kind of prototypical thoughts or expectations of a prototypical bird. So I would rely for the analysis here on some kind of Gricean principles of informativity. And the informativity is partly then dependent on what domains you normally associate with the words here. Somebody else, yeah?
There might be, and there probably are, like many other mechanisms that are independent of this. Like just to point out one example, that we can probably connect arbitrary concepts, like we can say about the word democracy, and they do not have inherently any kind of common domain, but we can still make sense out of it. So there are probably other operations with it.
Yeah.
No,
I mean, I mentioned this yesterday, the idea of I think a strong garden, You can tell a story where this makes sense. I mean, but it's not immediate. You have to make more difficult transformations than what you typically do in a situation. And we can make metaphorical, metonymical transformations that end up in some kind of meaning to this. And we are quite good at doing this. But we have some typical mechanisms, like plastic duck, stone lion, where we do we keep the shape of the objects but throw away everything else and so on. They're more or less easy transformations or constraints on these combinations. Metaphorical combinations. I mean, I will make a very long story short here by just giving you one example. I've given you a couple of examples of metaphorical uses of verbs, but let me just tell you how I go about analyzing metaphors in general. So the metaphor I'm looking here is that we've had a bumpy relationship. I think this example comes from Lakoff, but I don't know. So what is happening? How can we understand having a bumpy relationship? Well, it goes back to the original meaning of a bumpy road. I mean, bumpy, we know what bumpy means. It's a kind of spatial property. And bumpy means that this is something that is, it's about an object that is extended in a horizontal dimension, a bumpy road or something like that. So we have this dimension. This is a length or a spatial dimension. This is the extension of the road. And then bumpy means that there are some differences in the vertical dimension here. Sometimes it goes up and sometimes it goes down. So this is a curve that represents the bumpiness going up and down along the vertical line. So originally, bumpy is a spatial notion, and it involves the horizontal and the vertical dimensions. That's how we can describe the adjective bumpy here. Now, we go over to this kind. What we do here, unconsciously I would claim, is to make two standard metaphorical transfers. One is to map length onto time, or the other way around, map time onto the horizontal dimension. That's a standard metaphor. We talk about looking forward, it's been a long time and so on. We have this kind of spatial understanding of time. So this mapping is very common, time onto length. And then we have what Lakoff and Johnson call the more is up mapping when it comes to problem level. We map happiness or problems or something like on the vertical level. More problems means higher on that, and less problems means lower. So with these two transformations, we can then mentally form a kind of trajectory of how the relationship has looked like. So at the beginning everything was fine, no problems. Then we had a small crisis, but then we got back into a good period again. But then we had a bigger crisis, and now we are living under some kind of tension, blah, blah. You tell a story about the temporal development of the relationship. But this is thought of, I mean, you go up and down in the problem level along the timeline. Your mental construction of this story, of the relationship, has this shape. And these two shapes then are so similar that we can talk about it's a bumpy relationship. But what I'm doing here is that I'm taking two metaphorical mappings, time into length, and problem level onto the vertical dimension. And then in our minds, we do the cross product of this. We're not aware of it, but we form this kind of space, and we think of the relation in these terms. So I'm doing this example of a metaphor as a combination of two metaphorical mappings that are well known. But we are quite good at doing these things. And that means that, I mean, metaphor is more or less by definition a mapping from one thing to another. What I'm doing here is to take this idea of mapping seriously and look at the topological geometrical structures of the underlying spaces, and then using this structure to get the meanings out of it. I mean, I really take the spatial structures seriously here. Okay. you probably have lots of, I would have needed to prepare many other things about metaphor. But I should sum up now and give you some time for a discussion here. So I summarize by telling you a bit of what I've been doing here. I started by giving you 6 questions of semantics. What they should answer: the ontology, the semantic mapping, the social mapping, the epistemic, how we learn, and then connections to perception and action. And I think I've done that. I've done an analysis of domains based on the conceptual spaces. I forgot to say, by the way, that within cognitive linguistics, there is the notion of domain is used very often. And if you read Lakoff and Lannecker, they use domain extremely freely. And I'm a bit dissatisfied with the promiscuity of their uses. I have written another paper where I want to constrain the notion of domain. Lannecker has an example where he says that the domain of a finger is a hand, the domain of a hand is an arm, the domain of an arm is a body. He calls that domains. I think that's a misuse of the term domain. We can fight about what domain means. I would see this as kind of mereonomy, part-whole relations rather than domains. But he thinks of domains in that terms. I want to constrain domains to more spatial structures. This is what I've been doing here. And I've told you a little bit about how I construe the domains. I gave you this story about how we can know that we talk about the same things, and that depends on this kind of alignment or adjustment that we obtain in meeting of minds. And then I gave you, first of all, I gave you, the order should be, okay, model of actions and event based on conceptual space semantics of verbs. But I had this general idea, the single domain constraints for adjectives, verbs, prepositions, and actually demonstratives as well, maybe adverbs, maybe other word classes. I haven't gone through all of them. But this is a constraint that I claim will help children in learning words quickly. And I should have that earlier. That was the cognitive communicative grounding of word classes. And I gave you a little bit of ideas about how we can handle compositionality. I only talked about compositions of adjectives and nouns. I could extend it to noun-noun combinations. It wouldn't be much of a difference. But what we would need really is a compositionality for verb nouns and verb adjectives. All kinds of making sentences. I have some ideas, and these ideas would be dependent on the event model here, but I don't have time to go into it. So sorry, I'm going too far here. So that's a summary of the story. Most of it is in my book on the geometry of meaning, but there are some new stuff, demonstratives and so on. I haven't done in the book, but that's later work. So thank you very much. There we have maybe some minutes for questions. Yes, we do. Okay. Yep.
I have a question about demonstratives before. You showed a slide in which you said that demonstratives are present entities. In which sense do you intend that they are present? Because I was thinking, for example, that is not present at all. The demonstrative that.
Yeah.
In what sense?
Can you give an example of what?
If I say that book is.
Okay. Yeah. Yeah.
I mean something which is really far away from present.
Yeah. I once made a distinction between the fast coordination process and the slow coordination process. Demonstratives are part of the fast coordination process. And you can have coordination in the world. I point to say, and I say that bottle, and then it is actually present. But then I say that yesterday I put a bottle on the table, and that bottle then turned out to be leaking. Now I'm actually pointing, but I shouldn't be doing that. Now I'm involved in a kind of story. I'm building up a common ground, And when I'm saying that that refers to something present, I'm meaning that it refers to something that is present in the common ground of our discussion. That's the present I was referring to. It was a bit unclear, so thanks for the question.
Thank you.
Oh, sorry. Yeah.
I remember you have this slides of the word class and then the domain mapping. For example, verb would have a force domain. I was thinking there's well, I don't know whether that's nominalization, but you have a verb like a run, which can also have a nominal counterpart, like you take a walk.
Yeah.
And arrival. And how would you deal with this phenomenon? That would be a noun.
Yeah. I haven't really worked out that. I mean, I gave you the example of going from climb to climber in Lannaker. And what happens here is that you take the process, and then in the case of climb to climber, you focus on the object doing the climbing, and that turns out it should be an agent and so on in the story. In your case of a run, I mean, English is full of these nominalizations of verbs, very productive. It refers to an event. It's an event of running, and it's a period. I mean, it's a stretch of time where you're doing this running, and then you summarize it. You make it into the event. You make basically you objectify or nominalize the event. And we quite often do that. We talk about the party or the war and so on, which is where we make the events into an object. And I would say that a walk, a run, and so on are all cases of this kinds of transformation. It's not a full answer. I mean, I don't have a full theory of nominalization of verbs, but I would go along these lines, I think. Yeah?
Just make a small comment. Climb actually happened to be a favorite verb of lexical semanticists.
Yes.
Like, Sue Atkins and Patrick Hanks. I don't
Yeah.
know if you know these guys. And Spuck Fillmore. And there was a lot of back and forth what climb really means. And somebody pointed out that you can climb down a ladder.
Yeah. Yes. No. Good. Give me 2 seconds, and I'll go back to a slide that I skipped. And that's the slide. So, yeah, there we go. Okay. So it seems to involve both an upward motion and clambering. I mean, they're doing this. So it seems to be both a result and a manner verb. It's been discussed as a counterexample to this thesis that it's either result or manner. I analyze it as a manner verb, and the reason is that the force vector has an upward direction, even if the result vector is going down. The force, I mean, if you're climbing down a ladder, your forces are still directed upwards. So this would be my analysis. I separate the forces from the movement. So Oscar climbed the mountain is clear here. Oscar climbed down the mountain. You still do climb down the ladder is the same thing. Climb along the rope, you don't have to do the vertical, you can do a horizontal movement but still be climbing along a rope because the force is still directed upwards. You have metaphorical uses here, like to try and climb the mountain. And here the climbing is not clambering, but it's somehow pushing itself against the gravitation. There is a force that is directed upwards. But if you do it, the train climb down the mountain, you get a bit of problems. That seems difficult because now the force, you still have a force. Probably the train is braking while it's going down or something like that. But this is odd. This is odd because now there is no agentive. This clambering idea is gone with the train. So I get around the problem by this analysis that it's the force vector that has the upward motion, even if the physical motion, space motion is downwards. You.
I would like to ask you if do you ever happen to analyze drawings of children in order to understand
Analyze what?
Drawings.
Yeah.
How, for example, I was thinking in a project when you tell them to draw a tree, some children they draw it like small.
Yeah.
Or big or
Yeah. Yeah?
Or do you ever, like, because we were talking about children, but I think we were talking about the words they use, like mostly
No, I mean, I'm not. There may be a lot of work. I haven't really looked at it, but actually, it's a very good idea because children's drawings would reveal a lot about their ideas about the concept. You can do the converse, and you can look at children's picture books. I mean, when they have pictures of frogs and ducks and dogs and so on, they are very stylized. We heard this in the talk yesterday, that stylized pictures are more helpful than full pictures. And that's probably a good reason why you have very stylized. And what you get in children's picture books or when they learn animal terms and so on are just basically the shapes of the object, maybe a little bit about actions and so on. But I mean, it's a very good idea to look at children's drawing to see how they conceptualize different things. I haven't done it at all.
Because in the project that I'm working, in the pre-test and post-test, we are asking them to draw things. And sometimes instead of just drawing, they are adding like numbers like 30 degrees or the thing that something is hot. So
okay.
they're trying to describe the temperature or
Yeah.
the value of
Yeah, it's difficult to draw hot. I agree. Yeah, it's yeah. Okay, somewhere you in the back. Yeah.
Just wanted to follow up on the climb example. Like, I get the idea that when you climb down, that you're pushing upwards in order to get down.
Yeah.
But then you're doing the complete opposite in the case when you're climbing upwards. When you're applying force in the downwards direction, you get upwards. So it seems to me a little bit like you're choosing what fits this theory.
No, I'm looking at what my muscles are doing, and they're still pushing upwards, even if I'm moving downwards. I mean, that's the force direction is still upwards.
Upwards, I'm using the biceps, and then kind of downwards, I'm using the triceps. It's the complete opposite.
You beat me. That's fine. Yeah, maybe you could conceptualize it that way. Yeah. Okay. Okay. I have to think about that, but I still think that people normally think of climbing as an upward force. Yeah. Okay. Here.
As far as I know, all the words that face the road in the conceptual spaces are complete words. Have you thought about what kind of road is incomplete words? For example, prefix or suffix, phrase.
Yeah. I thought a bit about it, but as I said, I wanted a syntax-free semantics. And if you start talking about prefixes and suffixes, you introduce this kind. And of course, there are lots of linguistic variations between how you express things. So yes, I can start talking about meanings of different prefixes in German or and so on. And they would function as some kind of operator. I wouldn't separate. I mean, I'm not so bound with the definition of word here. I mean, as a lexical word, it's a kind of unit. Meaning units would be more general. So I hope I could extend my theory even to some kind of prefixes or suffixes or whatever. I mean, cases or other things. But I haven't done it. Yeah.
And concerning verbs, I also have a question. Do you have anything to say about light verbs? Like, I would do it, Like, can you integrate the light verbs also into your theory of verbs?
Yeah, to some extent. We have, I don't know, what is this term you're using, light verbs? What is this?
Like verbs which...
Yeah, I mean, these are verbs like... like do and become and have and so on. Are these the verbs you're looking for?
Like I would do it too.
Yeah. Okay. I would think of them as a kind of generic verbs. Do is a generic marker for a manner verb. It functions as a general manner verb. Become functions as a general result verb. And what else is there? Have is being in control of. Have is a little bit different for me to analyze. But the do and become are general markers for manner and result verbs. I would put them in that way. There are maybe a few other words like that, yeah.